we are recording right now, and I just wanted to say good afternoon, and I wanted to thank Kyla and Becca again for being here for the presentation today. And this is session D. It is titled Student Creation with Scratch. And Becca and Kyla are from Kids Code Jeunesse, and again, we thank them for sharing their experience and expertise today. So go ahead, Becca, whenever you're ready.
Thanks, Peter. So I'm just going to start with a little introduction to KCJ, kind of who we are and what we do. So on my screen, you should be able to hopefully see my presentation slides. I'll make it a bit bigger. And so today's workshop is all about Scratch. So I have a little picture about the Scratch homepage, and we're going to be using that later today. But just before we actually dive into things, I just want to take a minute to sort of explain Kids Code Jeunesse. So what we are a not-for-profit organization. We're based in Quebec, but we're actually all across Canada. We work with teachers, school boards, school systems, and individual classes and kids. So we go into libraries, community centers, kind of all around. And we teach coding, digital literacy, and AI. So we're actually the first national organization to educate about AI, including ethics. We're also the first to address the UN Sustainable Development Goals. So that includes climate change, gender equality, and poverty, and kind of making those part of our projects and our sessions. And we also have a huge dedication to supporting girls and children in underserved communities. So another little thing I just want to mention is this hashtag Kids 2030. So this is both sort of a mission statement for us as well as a goal. And the goal is to educate 1 million kids and 50,000 educators on AI and ethics, as well as technology. And this aligns with the UN global goals as well. So I know, I think there's still just one of you here, but if you do want to share your experience with us, you can screenshot or you could just post on Twitter, Facebook. We're pretty big on Twitter, so I included our Kids Coding as well as mine and Kyla's. So feel free to tweet or send us a message through that. And with that, I'll switch screens to Scratch. So let me just check in. So yeah, Kyla, if you want to hop off, feel free. I don't.
All right, thanks, Becca. I fully trust that you have this handled. So, but you can, Becca, if something goes AWOL, you can definitely just ping me in Slack. I'll be around.
Sounds good. Thanks. All right, so I'm gonna switch gears to Scratch now. So this is the Scratch homepage. Scratch is the website I'm gonna be walking you through today. So it's really an introduction to Scratch, what it is, why we use it, and block-based coding. So this is what the homepage looks like when you're logged in. You can see some of your friend or follower activity here. And then there's also a bunch of featured projects. So these can be posted by anyone in the world. And you can look through them, you can play on their projects, you can even see the code behind it. But the purpose of Scratch isn't really to see other people's projects, it's to create our own. So it's to get familiar with block-based coding and really create whatever ideas we have in the form of animations, video games, tutorials. There's a ton of different things we can do. Just a note about having an account. So because I have one, you can see my name up here. And if you do want to make one, you can actually make an educator account as a teacher, and that just allows you to have a bit more control. So say your students forget their password, then you can actually reset it for them instead of them having their own account at home. And you can kind of also just compile all of your classroom projects into one studio. So it does make sense to have an account. I definitely recommend it if you're going to be using this with your classroom. And with that, we can start coding. So next to the Scratch logo at the top is the Create button. And this is where we're going to go anytime we want to start a new project. So if you're on just the home page and you're not logged in, it might be a little bit different, but you can still create an entire project with no account. And so we'll give this a minute to load. All right, so now that it's loaded, this is the coding environment. So anytime you start a brand new project, this is the screen that you always see and the project that always comes to start. So it's actually just a cat right now, and I'll talk about that in a moment. But just in general terms of the setup, what we're actually seeing here is on the left-hand side, all of our coding blocks. So they're all categorized, color-coded. You can see motion blocks are all blue, looks blocks are all purple, sound is all pink, and so on. So one way to kind of get familiar and start to recognize blocks is through the color and the menu. And when you find a block that you actually want to use in your code, you can just click and drag and put it somewhere in this middle area here. So any blocks that you want to use, you want to have in your coding sequence, you put them out here, and now they're pretty much a part of it, as long as there's no major issues. Same thing kind of to delete it, or you realize you don't actually need this block, you can just drag it back to the menu, and it's no longer part of your code. So that's all that happens in the middle area here. That's how we add code. We can modify and customize it. And then on the right-hand side, this is known as the stage. So where you see the cat, this is where you actually have a box that you can create a project in. So whether you're making an animation or a game, you can, as you add code, you'll see the updates live as you add it. You can interact with it a bit, so you can actually click and drag on your characters and move them around. But other than that, you can't really do a whole lot with the stage. And these characters are known as sprites. So you'll see that word around a little bit. This character is called Sprite 1. Scratch always comes with one sprite, and it's always the cat when you start a new project. So that's just there because I believe it's their logo. And so down underneath the stage, you can see a little bit of information about it. You can see their X and Y coordinate position, the size, and the direction. And then below that, you actually see if you have more sprites than just the cat, you can go here and do some management there. Underneath that is this little cat logo circle, and that's the sprite library in Scratch. So if you click on that, which I'll do in a minute, you'll see a bunch of pre-made Scratch sprites that are already in the library. Beside that is the Choose a Backdrop library. So actually, I'm going to go there now. And is there any questions up to this point?
What age groups do you work with, Becca, when you work with Scratch?
So typically 3 to 8, grades 3 to 8, sorry, I should say. Ages like 8 to 12, but we have done sessions with younger kids too. There's actually something called Scratch Junior, and that's made for more like kindergarten to 2 levels. So that's really good too.
Okay, sounds good.
Yeah, so back to the backdrop. As you can see here, this is a library made by Scratch, so there are a ton of different objects. So really depending on where you want your game or your animation to take place, you have a lot of choices. So lots of sports fields, outdoor places, lots of space, and what else do we have? Dancing. Those are always fun with kids. But I actually just want to grab this XY grid right now. So I'm just doing this more as a demo, not to actually use, but this gives a little bit more of an understanding as to what's happening with the position in Scratch. So the coordinates are a little bit tricky. If you haven't actually seen this backdrop, you might not really know the range. So what it actually is X going from negative 240 to positive 240, and Y goes from negative 180 to positive 180. So when you actually get into the motion, and you use the X and Y values as movement, then it's good to kind of understand really how far it goes. So if you're only moving 1 pixel or 1 step, they call it in Scratch, it's really not very far. As you can see, the range is almost 500 across and 300 up and down. So you want to be moving in pretty big numbers of steps. And really with X and Y, something I'll say too is if you are working with younger grades and they maybe haven't really seen coordinates yet, it's pretty easy to avoid it altogether. You really don't need to get into it. But if you do want to get into it, if you are going through this lesson, you're teaching more X and Y in math, then there's a lot of ways you can definitely incorporate it and use this grid. So if I wanted to get rid of it, Actually, I'll just delete it so I have a white backdrop for today. And I'm just gonna leave my cat on the screen. And now I'm gonna go grab a new sprite. So I'm gonna go to this cat icon now, the Choose a Sprite library. And here are a ton of things. So there's characters, objects, really anything you can think of, and any sprite that you choose, you can add code to. So if you want to move something in your game or you want it to have some sort of purpose, then you'll have to add it as a sprite. So I'm actually just going to grab this beach ball. And if you're following along with me, feel free to grab it as well or something different. It doesn't really matter. But as long as you have two sprites on the stage, then we can begin to explore some of the movement and coding along with those. So I'm actually going to place my beach ball in the bottom right corner and leave my cat in the top left, like this. And I'm going to go and grab some coding blocks. So to start, I'm going to click on the Events tab. And these blocks are always the very first block that you start with. Anytime you want to grab a new sequence, you can think of event as input or trigger. So it's really anything that we have control of and we're saying to do something. So for example, the first block, when green flag clicked, this is pretty commonly used in Scratch. You can see there's a little green flag above the stage. So that's kind of used as a go or a start button. You can also use any of the keyboard keys as inputs. So when space key, up arrow, down arrow, any of the letters. You can use your mouse, so when you click on the sprite, and a couple other things that are less important. So today I want to use the keyboard key. I'm going to take out this when space key pressed. And another hint that the event blocks are always the first ones is that they're shaped a bit differently. So they're a little round at the top. You can't put anything above it. You can only stack below it. And I want my cat to actually move towards my ball. So I'm going to demonstrate this 3 different ways today. So we can really see sort of why you would use certain blocks in certain places and why you might use others in other situations. And also just see how some of the different motion block works. Because if you go to the motion menu, there's quite a few blocks in here. So it might not be super intuitive to know when you should use what. There's actually lots of different ways. In general too, just when you're coding, there's never usually only one right way to do something. So to get the same outcome, usually there's a ton of different ways you can code it. And that's where like the creativity really comes in. So I'm going to demonstrate 3 ways. But before I actually start moving, I want to add a reset button. So let's say I did get to the ball. I landed there. But now I want to try again. I want to try a new way to get there. I have no way to get back. So before I actually start coding my motion to get there, I'm going to code my way back. So it's always good to code a reset button if you can at the beginning before you get too caught up in your code and then you realize there's no way to actually go back to my starting conditions. So the first thing I'm going to do is take the go to XY block. And you'll notice that the numbers in here actually update and they correspond to where your sprite is placed right now. So that's where I put my cat. I didn't necessarily choose these numbers. If I wanted to move it over a little bit, I can see that they change, they update. And so this is, as I was saying, it's easy to kind of avoid understanding X and Y. This is one way to do that. So I don't need to know what these numbers are. I don't need to change them or care about them. I can just move my sprite and then I can add the block with the updated numbers for me. So I'm going to take go to XY and attach it to when space key pressed. So now if I move my cat somewhere else, anywhere else on my stage, other than that spot, and I press the space key, I see it goes back exactly where I told it to go. So that's good. I have part of my reset button, but actually I'm going to leave it for now. And kind of throughout, I'm going to maybe miss some steps, but then we'll see why I do that. So you can actually see each iteration and what's actually happening when we maybe don't have our full code complete. So as of now, it looks good. It looks like my reset button works. So I'm going to move on and start my first motion. And to do that, I'm going to go back to events. I'm going to take out the same block, actually when space key pressed, but this time I'm going to use the number 1. All right, so back to motion. And I'm going to start with, before I actually move, so actually let me just take out the move block just to give you an idea of what happens. So as I said, the steps are the pixels in Scratch, and that's how far I'm going to get. So if I press the 1, you can see my cat does start to move. If I keep pressing it, it's moving 10 steps every time. So it's really not actually that far. And I'm going to go back. So I'll separate this block out for now because we have an issue. If I move, I only move across the screen to the right. And I'm not moving in the direction of the ball. So I'll never get there. I'll only get to the end of the stage. So before I move, I actually need to rotate myself. And I'm going to do that using the turn block below it. So your sprite, if you're using the move block, it only moves in the direction it's facing. And by default, all the sprites in Scratch face the right. So even though they don't always look like they are, like the ball doesn't, you wouldn't really know, you can tell the cat is, but that's the way they always move by default, to the right. So if you want it to be any other direction, you have to set it. So you can either turn them, you can point in a different direction, which we'll see a little bit later, but I'll use the turn degrees for now. So again, if you're getting more into like math and degrees, you can definitely teach it using Scratch. It's a lot of fun. There's a lot of different ways to do it. But if you don't really want to, if your kids are maybe a little bit on the younger side and they don't understand degrees yet, a little trick is if you actually click, not in there actually, but if you use the direction tool down here and the other block we're going to use later, you can just use the arrow direction. So you don't even need to use numbers at all. You can turn your Scratch characters by just using the direction of the arrow. But I am going to use degrees for this example. So if I press 1 right now, you can see my cat starts to turn. So it turned 15 degrees, not super far, but it might get there. I could try it again though. So if I press 1 again, maybe that's a little bit better. So I pressed it twice, which means I actually turned 30 degrees. So to make my life easier, I'm just going to type in 30. And then I only have to press it once. But now let's say I want to reset. I want to go back to my starting point and try turning again. I'm already turned and I have no way to get back. So I could keep pressing 1 until I do a full circle. Should I get there? That looks good. But to make my life easier, this is where I'm going to add another block to my reset so that it always faces this way to start. So this time I'm going to use the point and direction block. And 90 degrees is actually the direction to the right by default. So I'll leave that as is. Now if I press 1 and space, I turn, but I also go back. So now that I turn, I can start moving in that direction. So if I try connecting these, I can do 1. I press 1, I can turn 30 degrees and move 10 steps. But it's still definitely not enough steps. It's way too small. So one thing I could do is try changing the number. I could try guessing how far it is. So maybe it's 300 steps away and not quite. So I'll go back. I'll try 400, a little bit closer, maybe like 450, 420. And pretty close. Okay, that's good enough. And that's just one way to use the move steps block. But what happens there is my motion is very jumpy. It jumps all the way across, and you don't really see it happening. So one way to fix that is to actually use a repeat block. So in the control block menu, the orange one, there's a block called repeat. And the way this block works is whatever you put inside of it starts to loop around. And you can set it for as many loops as you want. So I'm gonna put this repeat block around my move block, and I'll change it back to 10. And if I repeat 10 steps 10 times, I know I'm gonna get 100 steps. So if I demonstrate that, I still don't get far enough, but you can actually see each 10 step happening. It's really fast, but you can actually see the movement a bit better. So I'll make this maybe 45 because I knew it was close to that. And now if I press 1, you can see that I'm actually taking 10 steps 45 times. So it's still really fast. It only happens in a second or two. But instead of it jumping all the way to the ball in one motion, you do start to see it kind of slide towards the ball. So that's a little bit better. And then one more thing that we could add to this one is a bit more control, which is a weight block. So what's happening right now is that the very first block, turn 30 degrees, is also kind of happening at the same time that it starts to move. So you don't really see it turn. You do a little bit on mine because I think it's just lagging. Usually it happens faster than that though. So what I'm going to do is add this weight block. And what that does is just kind of pauses the program for a second. So often in Scratch, the code is running really, really fast right after itself. So a lot of things happen kind of instantaneously and you don't get to see them. But adding a weight block in between blocks of code in your sequence can allow you to actually visualize what's happening. So if I press 1 now, my cat turned, it did wait a second, and then it started to move towards my ball. So that's optional, but it's good to kind of play around with too and see where it's useful, where it's not, and it can be really helpful. You can also change the time of the wait. So if you want longer waits, you can do, I don't know, 6 seconds. I just typed in 0.5. So if you don't want it to be as long, it's definitely useful to have that. And with that, I think we can go on to the next type of movement. So I think someone else actually joined us. Welcome, Rebecca. So if you actually missed anything that I said up to now, let me know if there's like key things. If you're just like, what are we doing? What are we on right now? I can go back and explain a little bit. We're using the Scratch website, and I'm just demonstrating some of the basic building blocks and getting familiar with using block coding. And is there any questions up to this point? You can ask questions throughout in the chat too, and when I come back and check, I'll answer them. If there's anything you want me to repeat as well, because there's such a small group, I don't mind just going back and showing it again. And so now that we've added our first type of movement, I'm going to demo another type. So I'm going to go back into events, kind of the same start every time. I'm going to take out the exact same one. And this time I'm going to set it to the number 2. So just to keep my methods of movement organized, I'm just using 1, 2, and 3 today. These can really be whatever you want though. Another thing I'll mention is sometimes this is confusing to kids or even teachers where the blocks, the sequence of codes actually go. So they're all independent of each other. It really doesn't matter. I can stack these in whatever order I want. They're not actually touching at all, so they have no link. Sometimes they do. You can sometimes make blocks of codes kind of communicate with each other. We're not really going to get into that today though. So they are pretty independent, and it really doesn't matter however you want to line it up. Some people like to put all their blocks in one nice vertical line. That can get really long though. You can put them side by side. So however you like your blocks to be organized is up to you. So I'm going to start with 2 here. Here, I'll switch these back so they're just in the order I taught today. And when I press 2, so this time I'm going to do something a little bit different. I'm going to go back to motion though. And I'm going to use the block that says point towards. So below the point and direction block, we use that as part of our reset. This time I'm going to use point towards. So this can be useful if you have a specific sprite that you know you always want to point towards. So you can click on the drop down and instead of mouse pointer, select beach ball. And now if I press the 2 key, then my sprite actually points directly towards that. So again, this is kind of another trick if you're trying to avoid angles altogether. Instead of trying to figure out that it was 30 degrees, you can just use the sprite itself and the center is automatically aligned. So you're actually going to get the most perfect point towards in degrees. And after we do that, we're going to glide. So instead of taking steps towards the ball, we're going to use this block called glide 1 second 2. And it says random position right now. So I can actually leave it like that and just show you what that looks like. So if I press 2, I glided 1 second to a random position. So every time I do it, I'm going to get a new random position. And I'm kind of facing all different directions because the beach ball is always in a different spot relative to where I start. But I'll reset that. And that doesn't really make sense. We know we're trying to get to the beach ball. So I can again use the drop down and select the beach ball sprite. And it's going to go exactly there. So now if I press 2, I point towards it and I glide towards it all in one step. That was pretty easy. So, and it actually got there perfectly. I didn't have to like try to guess. It wasn't like close enough to the beach ball. Their centers actually lined up perfectly. So you can see already that this way might be a little bit better in certain situations, but there's definitely a reason why we can't always use it. So let's say, for example, we didn't have this beach ball. It was gone. I'll leave it. But say that we were actually using maybe just a part on our backdrop, we didn't have a sprite to necessarily get to, then we would have to do it more manually. Also, if you do want to actually kind of see what's happening behind the scenes, it's good to use these. So even though we had to kind of iterate, guess and check with our numbers until we got them, we really see exactly what's going on. So we see that we're turning 30 degrees. We're taking 45 repeats of 10. Here we have really no idea. It's kind of doing the work for us. So there's already 2 different examples of how we can get to our beach ball. I'm going to do a third now. It's going to combine some of the stuff we already used. But we'll see an extra bonus thing at the end too. So again, I'm going to take out the same event. This time I'll use the number 3. And I'll go back to motion. This time I'm going to use the same point towards. So that one worked pretty well. It was easy. I could use the degrees again. We know that it's about 30, maybe 35. But there's really not any other good way to turn. So I'm going to use that one again. And this time, instead of glide to random position, I'm going to use the one below that. So this one uses X and Y. So you kind of have to know what's going on. But again, not really. So remember how I said at the beginning, if you move your sprite, then the numbers of X, Y actually update for you. So if I just put it on the beach ball where I think it should land, and then take this block out, it already updated X and Y for me. So I didn't even really need to know exactly where they are. If I wanted to be more precise, I could click on the beach ball sprite and see that X is actually 197 and Y is negative 139. Whereas I think, yeah, mine was 202 and negative 129. So it's not perfect. If I wanted, I can click on here and type it in and change it like that. Or I can guess and check and say, that's good enough for me. So depending on the purpose and how precise you really care to be, you can use the numbers exactly or just estimate. So if I click space, I'll reset and use these 2 blocks. It looks really similar to the second one. So it's still that glide motion. It doesn't jump there. It kind of glides across the screen in 1 second. But now let's say I move the beach ball across my screen. So this could be, oops, I didn't mean to do that yet. Let's say you're making a game where you have some sort of moving target. just for an example. And now if I used the second method, so if I use key 2, I'm going to point towards and glide towards. So these always work. And no matter where I put my beach ball in the screen, I'm pretty confident that these blocks are going to get me there. Whereas now, if I use the 3 key or the 1 key, I don't get there because I go to this specific location every time. But this could also be good because if I always want to go to a specific corner and it's not necessarily tied to any sprite, then I would have to use this method or the first one. So I'll put it back for now. And there's one last thing that's kind of not necessarily has to do with the motion, but it's a pretty important block in Scratch, and it's good to know how it works. So under the control menu, there's a block called if then. I'm going to take that out and put it below my third one. I could really add this on to any of them, but I'll just do it on my third one since we're working on that. And the way that this works is it's a logic statement. So it's checking whether or not something happened, if a condition is true or false. So these are really, really common in coding, pretty much definitely all games, and I would say even most animations use at least some sort of if-then block. And so how it works is I can check whatever condition I want in here in this little kind of diamond-y shape. There's room for me to put another block. And then only if that condition is true, then whatever I put inside of this will be executed. Otherwise, it's just going to kick itself out of that loop and it'll do anything below it. So to get that conditional check, most of the blocks are either in sensing or operators. I'm going to use one in sensing for this project, and I'm actually going to use the second one. So this is touching color. So just as a quick note, if you do want to use this for like math problems, if you are more into that, then under operators, that's where you would find like addition, subtraction, multiplication, and division blocks. You can use these equal sign blocks, so you could check if something was equal to a certain number. If you're making like a quiz, you could check if your answer was correct using that. So it's also really commonly used, especially in games too, if you're checking if your score reached a certain value, or if your timer ran out, it reached 0. That's where you would find those blocks. But for the purpose of this, I'm actually just checking if my sprite, so my cat sprite, is touching a specific color. And I want to actually check if it's touching my beach ball. So did it get there successfully or not? So I can use one of the colors on my beach ball. And an easier way to do it, instead of trying to determine the exact saturation and color number on the wheel, is if you actually just click on this little paint dropper icon below, and you'll notice your screen goes brighter. So you want to hover over your beach ball and click on somewhere where it's red. You could also use the orange, but that's kind of too close to my cat. So I'm going to use the red one because nothing else is this red. Click on that, and then it automatically updated the exact shade of red for me. So now I know it's checking if I touch that color. And if I do, I'm going to introduce another new block here. So I'm going to say a little message. And by say, I really just mean put a speech bubble of a message up. You can use sounds. That's a lot of fun, but I'm not going to do that right now. I'm just going to use the very first block in looks that says say hello. So let's test it out. If I hit 3, so I got to my beach ball. For some reason, I went behind it in this case, which can be fixed. Excuse me. But if you noticed, it was quick, so I'll do it again. My cat did have a little speech bubble that said hello above it. And this is also customizable. So anything white with text in it, you can change. I can say congrats, or I could say like that's good if you're maybe making a game and you got to the goal. I could say like you reached the beach ball. So this can really be whatever you want. I'll try that again just to show that it updated. And so now let me just move the ball again. And now I'll use the 3 key again, which I know always gets me to that corner. But this time that conditional didn't kick in because I wasn't touching the color. So it checks for this condition. If it's true, only then will it say this message. Otherwise, it's not going to do anything. So are there any questions up to this point? Everyone is
really. I've been following you along, Becca, and trying to basically duplicate what you're doing. And
awesome.
It's pretty cool, like different ways to move around and just to see different, like you were saying, there's no one correct way of doing it. You can do it 4 different ways, basically, is what you're showing. So.
Exactly. I see kids come up with new ways every day too. Like I'll tell them to do a certain thing. Sometimes I challenge them before I actually show them how I would do it. And there's always like so many new ways they think to do it. And I'm like, I never even knew that blocking existed or like how that worked. So it's pretty awesome to see. That's why coding is a really good like problem solving tool too. So instead of once kids kind of know the basics, at least to stacking blocks and modifying their code, to give them a problem and see what they come up with. So there's almost never one way to do it. And it's really cool to see what kids come up with and how they get to the same result. So this is what I have for the main project that I wanted to do today. I have a couple other things I wanted to just share as extra resources and how you can keep doing this. If anyone here, I know we're a super small group, 2 of us, but if you guys wanted to just like have me demonstrate any other specific blocks, I can. So like we didn't do any sounds today. These ones are pretty straightforward though. But if you do want me to like actually use any of these blocks, I can. But I will say I have total faith that if you guys kind of understand the basics of taking blocks out, stacking your coding sequence, moving them around, then you can definitely figure out a lot of this on your own. You can play around with it, which I would encourage you to do. So try using different blocks, click on them, put them into your code, see how they work, challenge yourself to make a project. And with that, I'm going to switch over to this page of links. So it doesn't look like there's any questions in the chat. I'll take that as a good sign that you guys followed along. So this I'm going to share with both of you guys who are in the session today. And I'll try to also share it so that if you are watching the recording that you'll have access to this because it has a lot of good resources in it. So I also shared my email. I'm in PEI. So if you're watching from PEI or New Brunswick, then I can help you. And I'm the facilitator and community developer there. So for today's session, we use Scratch. I just linked the home page and then also the ball and cat project. You can click on this link. And this is one I did a couple months ago, I think. But I'll just also show you what it looks like if you're going on Scratch from an external link. So if anyone's published a project, that means they've made it accessible to anyone in the world, anyone can see it, then you can share their project page, you can go to their project page, you can actually play it. So I can see what I did last time, if I did anything differently. That time one didn't even get me to the ball, so maybe this one isn't the exact same. But if I went to see inside, I can actually see, this happens to me in my own code, but say you guys went to it, you can see inside my code and you can actually remix the project, which is just the term for making it your own. So you can kind of save it to your own profile and add your own code and modify it from there. So I can see my code from it last time. And that's a little bit on how the project pages look in Scratch. So below that, we have this really awesome project too, which if we do these in person or we have more time, then we usually get teachers to try out this map remix project on their own. And essentially it's the same idea of what we did today, but instead of a cat trying to get to a ball, your character is an airplane and you're flying around the world. So suddenly it becomes sort of a geography lesson. We made the background a map of the world. So we'll see in a second when it loads. And you can use this link as a starter project too. You can remix it so that you can make it your own. But essentially, this is our plain sprite. and you can use the different motion tools. So you can use glide and move. You can incorporate if loops and stuff and make it more of a geography project. So I'm not going to go through all of this stuff, but I just wanted to show you that one, and I would encourage you guys to try it out on your own. There's a lot more links here. These are all really good. They're project ideas that link to specific curriculums and specific courses. So if you're looking for something more math, geography, science, whatever it is, you can definitely find projects that link to the curriculum through these. There is also a link to our KCJ training website. So a lot of the time when we go in person, everyone's on their own computer, then we actually get them to log into this. And again, here you can actually see everything I did today. So there's a step-by-step instructions to the cat and ball project. So it has all the code. So if you weren't actually doing it today, no worries, because you can find it all on here. And there's also some extra explorations as well. So up here, I'm just going to click on it briefly. And on the side here, you can see, so there's a Scratch presentation, there's a quiz, there's drawing in Scratch, and then there's a couple microbit things, which we didn't do at all today. But I do want to mention also, so if you do have time and you want to go through these are also pretty step-by-step. They'll tell you what to do, but you can challenge yourself, try to do it on your own first, and then come back to the instructions and see how you did. So that's the teacher training site. Below that, there's links to our website. So let me just see. Yeah, this is our general website. You'll probably mostly be on the educators tab, which I'm going to show you in one moment. Before I do, I'll also mention, okay, no, I'll mention this all on the website. So just the other things that we kind of do and how you can be more involved with Kids Code Jeunesse and other things that we can offer you. So like, I think I said this at the beginning, but we do work with classrooms directly, as well as students in different communities. So one thing that we offer is Code in the Classroom workshops. They're actually all online this year. We have decided not to go back into classrooms this school year. So if you do sign up, as long as you're teaching online, if you have your class through some sort of online or blended learning for at least an hour, then we can come in as a guest. So myself or one of our other instructors across Canada can do a live coding workshop. And we can actually do that through Scratch, sort of like what I did today. We'd actually complete a whole project. We can also do microbits. And then the third one is AI. So if you go to the educators tab and then Code in the Classroom, scroll down a little bit, there is an apply now button. This is a little bit confusing because we're in the process of updating our application. So this one is actually only for Scratch. You can read it here. But if you do want the microbit or AI one, you have to go down and fill out our old application. If you actually click our link in like a week or two, this should all be fixed and you'll probably only see one application. But just for now, if you are doing it early, you can apply for a workshop here. So you just have to tell us like your school name, what grade you teach, and we can set up a workshop for you. So a bit more on microbits. If you guys aren't familiar with what those are, let's see, I have one here. Oh, no, I don't. Okay, I had one on my desk, but it's actually just a little piece of hardware, kind of like a mini Raspberry Pi. People are more familiar with, and essentially you can code it online. So it's very similar to Scratch. It's block-based coding, but then you can actually transfer the code that you made onto the microbit itself. So this is like the box for the microbit, but I don't have one in here, but it's actually that like really little thing that girl's holding. A lot of schools have them. You guys probably have some sort of familiarity with them. But we do also, we're able to send them out to schools if your school doesn't already have them. So if you book a workshop with us, then we can provide you with some microbits. And yeah, you can read more about it through here. Teacher training, this is what we did today. But again, if you wanted to participate in our AI or our microbit one, you can sign up through here. You can do it with your school privately or with even just a group of teachers. So you're more than welcome to look through this, register through that. And I think that's pretty much it for me. So there's more information about microbits here, registering for a workshop and an individual teacher training, who you can contact. And then the very last thing is, if you want, you can fill out this survey. So I'm going to send the link to this in the Teams chat. And then I think Peter also has a survey for you guys.
Yes, thanks a lot, Becca. I'm going to copy and paste the link for prizes in the chat box as well. And a lot of good resources, Becca. And I think teachers will really appreciate this and be able to access the links and to watch the step-by-step coding videos. There's always interest in Scratch, and it's so accessible to students that I think it's going to be very valuable for teachers and students this year.
Definitely. Yeah, awesome. Well, thanks for coming.
Yes, a small crowd, but quality
Yeah.
over quantity this time, Becca. And I just wanted to say a few things. This concludes our session. We want to thank Becca, and Kyla was here as well early in the presentation, for taking the time to be here today. There's a closing ceremony at 3:45, which involves a message from MBTA President Rick Cumming, and a recognition of Brian Facey, as well as prizes after that as well. So thank you again for everybody for taking the time today, and have a good afternoon.
All right, thanks, Peter. Thanks, everyone.